Welcome everyone. We already learned about data. Data must be stored efficiently and secure. Even if there is an issue either hardware or from software side, we must be able to prevent losing our data because data is very expensive and invaluable. One solution is RAID. So today we are diving into RAID, which stands for Redundant Array of Independent Disks. In this lecture, we will learn what is RAID, where it can be used. We will learn different level of RAID, and also we will learn how to select which level of RAID. Here we go. RAID is all about smart disk organization techniques that help us to manage a bunch of disks efficiently. The goal? To make it look like we are working with just one super disk. One that offers high capacity and speed by running multiple disks in parallel, and high reliability by storing data redundantly. What are the advantages of RAID? Why it is such a game changer? First, it boosts performance. How? By using multiple disks in parallel, like RAID level 0 or 5. Later, I will explain what is level 0 and 5. We get faster data access, perfect for demanding applications. Second, RAID enhances reliability. Redundancy in levels like RAID level 1, 5, or 6 ensures our data stays safe even if a disk fails. Third, scalability. RAID lets us manage tons of disks as one seamless unit. It's also cost effective, with options like RAID level 5 striking a great balance between performance and protection. Finally, flexibility. Whether we go software or hardware implementation of RAID adapts to our needs. It's a powerful tool for any storage strategy. Here, we have a variety of storage devices like hard drive, SSD, USB drives, and even multi-disk RAID enclosure. In this image, we can capture the essence of RAID. It means combining multiple disks to work as a single unit. So you can see here, RAID is combining two memories or multiple flash memories or multiple hard disks or multiple SSD, right? The flexibility makes RAID a powerful solution for everything from small scale to enterprise storage needs. Next up, let's talk about RAID levels. These are different schemes designed to balance redundancy and cost, often using techniques like disk striping or parity bits. When we evaluate RAID levels, we look at three key metrics: cost, performance, and reliability. There are, in general, seven level of RAIDs, starting from RAID level 0 to RAID level 6. Each one has its own unique approach, and we will break them down one by one in the coming slide. Ready? Let's start with RAID 0. Here is RAID level 0. This one is all about speed. It uses block striping, which means it takes sequential data like a file and splits it into chunks stored across different disks. So you can see here we have two disks here, and we divided the file, and first block on this disk, second block here, third block here, fourth block here, right? And so on. Odd blocks on one disk and even blocks on another disk. Think of it as dividing up the workload for faster access. It needs at least two disks and delivers excellent performance, making it great for high-speed applications. But here is the catch. There is no mirroring or parity, so there is zero redundancy. It means if we lose one of these disks, half of data already gone, right? So if a disk fails, our data is gone. So don't use RAID level 0 for anything critical. Speed comes at a price. Now, let's move to RAID level 1. This level focuses on reliability with mirror disks. Every piece of data gets duplicated across at least two disks. It still uses block striping for efficiency, and it's known for offering the best write performance among RAID levels. We will see it in places like database system for storing log files where uptime is a key. There is no striping or parity here, just pure mirroring. So you can see here we have two disks and each block of data is copied twice. This is called as mirroring. Each block of data is stored twice, one on one disk and another on another disk. So, with good performance and excellent redundancy, it's a solid choice when data safety matters. When we want to keep our data, we store our data simply on two disks, and if we lose them, still we have backup. Alright, here RAID level 2, a bit more complex. It uses memory style error correction code, or we call it as ECC. This combined with bit striping. Imagine you have got data bits like B1, B2, and B3 written across disk, and then extra bits like E1, E2, and E3 for error correction. When you read the data, you grab both the data and these codes. If something goes wrong, the system uses those codes to fix the data on the fly. And you can see the image here. This is for RAID level 2 configuration with two data disks. This number 1 and this number 2. Storing data bits from B1, B2 up to B6, and also we use bit level striping here. And also we have two other disks, these 3 and 4. They hold error correction codes from E1 to E6. It's clever, but as we will see later, it's not widely used today. Let's keep going. Next up is RAID level 3, which introduces bit interleave parity. This level uses a single parity bit to handle error correction. When you write data, the system calculates parity bits and stores them on a dedicated parity disk. If a disk fails, you can recover the lost data by computing the XOR of the bits from the remaining disk, including that parity disk. It's a neat way to add some redundancy, but like level 2, it's fallen out of favor over time. This is a RAID level 3 with 4 disk configuration. Data is stripped across the first 3 disks, and so we can say A1 to A6 on here, while the fourth disk is dedicated to parity blocks like AP and BP, something like that. This bit interleave parity enables recovery from single disk failure, though RAID 3 is less used now due to its reliance on bit level striping. Onward to level 4. So RAID level 4 steps things up with block interleave parity. Here, data is striped at the block level across multiple disks, and separate disk holds parity blocks for error correction. When writing, it computes parity for each block and stores it on that parity disk. If there is a failure, recovery comes from XORing the corresponding blocks from the other disks, including the parity one. And you can see here the image. We have 4 disks. So data blocks A1, B1, C1, and D1 are striped across disk 0, disk 1, and disk 2, while disk 3 is reserved for parity blocks like AP, BP, CP, and DP. This dedicated parity disk enables data recovery in case of a single disk failure. Though RAID 4 is less popular, due to potential performance bottleneck on the parity disk. It sounds promising, but RAID 4 is not commonly used today. There are better options as we will see next. Now we are at RAID level 5, a fan of favorite. This uses block interleave distributed parity, spreading both data and parity across all disks. No single parity disk here. For example, with 5 disks, the parity blocks for the nth set of block goes to disk n mode 5 plus 1, while the data lives on the other 4. You need at least 3 disks and it delivers good performance and redundancy. Plus, it's the most cost-effective option out there, making it a go-to for many systems. You can see here in this image, this is a level 5 configuration with 5 disks, where data blocks 0 to 19, for example 0 to 19 here, are striped across disks, and parity blocks like P0, P1, P2, P3, P4 are distributed among them. This distributed parity allows RAID 5 to recover data if one disk fails, while striping ensures good performance, making it cost-effective and reliable choice. Pretty impressive, right? RAID level 6 takes redundancy to the next level with P plus Q redundancy scheme. RAID level 6 stores extra redundant information to protect against multiple disk failure. This makes RAID level 6 more reliable than level 5, but that extra protection comes with a higher cost. Because of this, it is not as widely used today. It's a niche choice for those who need maximum reliability and can afford the cost. You can see here in this image, data blocks like A, B, C, D are striped across 5 disks, and two parity like P and Q, you can see here, two parity blocks like P and Q are distributed across all disks. This dual parity approach allows RAID 6 to withstand two disk failures, providing enhanced data protection compared to RAID 5. Now, let's figure out how to pick up the right RAID level. How do you choose the right RAID level? Level 0 is your peak if data safety is not a big deal, like when you can recover it elsewhere. Level 2 and 4 pretty much never used. Level 3 outdated, and level 6 is rarely used. That leaves level 1 and level 5, which cover most needs. Level 1 shines with better performance, perfect for high update setups like log disk needing just 2 write per block, while level 5 needs 2 reads and 2 writes. Level 1 costs more in storage, but with today's big drives, that's often not an issue. So, level 5 wins for low update, big data scenarios, and level 1 takes the rest. Let's talk about implementation. RAID can go two ways, software or hardware. Software RAID runs purely on your system software, no fancy hardware needed. Simple but limited. But in case of hardware RAID uses dedicated gear like non-volatile RAM to track writes in progress. It's more robust, but watch out. A power failure mid-write can still corrupt your disk. Both have their place, depending on your setup. Next, let's tackle some hardware challenges. Finally, let's look at the hardware challenges. Latent failure. Latent failure can sneak up. Data you wrote ages ago might get damaged. Data scrubbing helps. constantly scanning and fixing issues using copies or parity. Next, hot swapping lets you swap disk without shutting down. Super handy. Some systems keep spare disks ready to jump in the second a failure detected. And to avoid a single point of failure, top tier setups use redundant power supplies, controller, and connection. It's all about keeping things running smoothly. That is RAID in a nutshell. And that brings us to the end. RAID is all about boosting storage performance and reliability, giving us tools to handle everything from high speed tasks to critical data protection. Today, RAID level 0, level 1, and level 5 stand out as the most relevant levels, each tailored to balance cost, performance, and redundancy based on what you need. With software and hardware implementations, there is flexibility to fit any setup. In a world where data is king, RAID remains a cornerstone of modern storage management. Thank you for your attention and feel free to drop a comment under this video with any questions, comments, or concerns. Thank you.